and hopefully get relevant, right? Actually, we've had some relevant conversations. I mean, it's your life, you're getting to know each other. Now, speaking of that, getting to know each other, and no, I'm not Julie Anders, and I'm not going to sing the song from Sound of Music. Now, what I would encourage you to do, highly encourage you to do, is find at least 3 or 4 people in this class that you feel comfortable with, exchange phone numbers, okay? That way you would have kind of a study buddy. You get stuck while you're working on the homework, someone you could call. And because sometimes just one word is enough to stop your block and you can keep going, okay? I've had groups that have formed that sometimes have sat out here in the lobby before or after class working stuff and studied together for tests. And so that's something that I would highly encourage you to do. I've found it to be very productive for my students in the past. So enough said about that. A little harder in the online class. All right, well, what we're going to do tonight, if I can find my clicker, we're going to take off where we were. Oh, one more important interruption. This announcement is brought to you by Labor Day. No class Monday. Do not come. I won't be here. The room door will be locked. The front door will be locked. Okay? All right, now that said, absolute value equations. We actually, I'm going to do about 2 or 3 slides to kind of repeat where we dropped off last night, because some of you have reached your level of saturation, and I could see it in your eyes, that blank look and all of that. So anyway, we had this. The statement of absolute value of x equals 5 actually means that you could have a positive 5 in there to get a 5, or you can have a negative 5 in there to get a 5. I've got 2 people in now. Let me start chat in case they have a comment to give me. And it's already recording. Sorry about that. All right, now, going on from here. Now we can, since the absolute values are gone, we can add the 3 to both sides, getting this. Over here, we added the 3 to both sides, getting that. Simplifying it, divide both sides by 2. Here's the check of this to see if 4 is a true statement, to see if -1 is a true statement. Okay, so if we let W equal 4, we go back to the original problem. We substitute the 4, always using parentheses for our substitutions. That gives us 8 minus 3. Absolute value of 8 minus 3 is absolute value of 5, and absolute value of 5 is correct, so it checks. Same sort of a thing on this, on the -1. Yes?
So going back to when you did the adding or subtracting the 5, I'm just trying to understand.
Right here.
When I were to look at that, if I were to look at that on Alice, I feel like I personally would only take subtracting the 5 because of the part. So can you help me understand how you're able to add or subtract it in this kind of equation?
If you graph this equation, okay, you're going to get a graph that's going to look like this. This side of the graph Here's the y-axis and x-axis, for example. This side of the graph is going to be generated by the positive side. This side of the graph is going to be generated by the negative side. So yes, you must do both sides. Now, in a likewise analogy, if I had the square root of x equals 4, I would have, excuse me, if I had x squared equals 4, and I took the square root of both sides, I also would have to do a plus or minus function for a similar reason, because in that case, we would have a graph that would look like this, representing the positive and the reflected symmetric negative side. Okay? Now, this one in particular, where the 4 and 1, it's actually going to be scooted over where the 4 is more emphasis. Okay? But that's just kind of a general illustration of why we have to do that. Is because by the nature of absolute value, there can be both a positive and a negative answer. Same thing if you take the square root of both sides. Okay, I hope that that helped. Okay, so there's your solution set. Another equation. This time, that 6 is an external add-on. So yes, we do get rid of it first, because we've got to have this absolute value all by itself. It's not friendly. Okay, it doesn't like company. So we do that. -6 both sides. Now, guess what? Absolute value negative. We can work this thing, but ultimately, yes, it's pointless. But let's say you did work it. Okay. This generates two problems. For the plus side, 2c minus 5 equals -4. For the negative side, 2c minus 5 equals -4. 'Take this over. 2c equals -9. Duh. Over here, take that one over. +5 + 5. And 2c equals 9. Okay, wait a minute, I should have +5 here and +5 here. So this will be a +1. Okay. Now, divide both sides by 2, and I get c equals +1/2. Over here, divide by 2, and I get c equals 9/2 or 4.5. Now, let's check those. Absolute value of 2 times 1/2 minus 5 equal +6 equals 2. 2 times 1/2 is 1. What?
Wouldn't that be 9/2?
Where?
Or 9/4?
Yes. Thank you. Good thing I wasn't there yet. So this is 1 minus 5. Okay. And which gives me 4. And +6 equals 2. So then take that over. Excuse me. This is 4. All right, yeah, it's 4, right? I'm doing order of operations. I'm not solving. Plus 6 is not equal to 2. That's 10. What about this side? Absolute value of 2 times 9 halves minus 5 plus 6 equals 2. 2 times 9 halves is 9 minus 5 plus 6 equals 2. And this in turn gives me 4 absolute value of. And 4 plus 6, again, is not 2. Okay, and that's kind of a proof why this thing is true. Okay, it's a whole lot. I mean, you can work it, but you're going to get a falsehood. Okay, and you spent 5 minutes when you didn't need to. Okay, but I think it's maybe good that we showed this just simply to prove that point to you. And ultimately, even if you don't recognize that to start with, maybe, just maybe, at some point along the line, you will, or eventually if you check it, you'll see that you have an issue. Okay, so no solution is the answer. Very long-winded answer to a short problem. Okay, here's another one, even more complicated. Okay, whoops. Well, that's one we can work or don't work. I'm going to go on tonight because I like fractions. Okay, now, what do we want to do? We want to get rid of that thing. Okay, so we're going to add a positive 7 to both sides, which gives us that. Now I want to get rid of this thing. Okay, so I'm going to divide both sides by -2. Remember, if this were an inequality, we'd be flipping sides. If it were. You look a little puzzled. Okay, after I do this division and hopefully reduce that, then you remove the absolute value signs. Yes. Okay, and I'm just bringing this down. So here's what we had before, that stuff, after we did all the canceling. So we just brought it over to this page. And here's that same statement again to remove it now. Now that we have it totally isolated is the point. Okay, so that gives me my 2 values, my plus and my minus. I tell you what, for me, it really does help me keep from mistakes. If this very next step, when I take off the absolute values, I put that little plus and minus and then write these. It really helps me personally not to only do one side. And every semester on the final, that's going to happen. Probably 15% of you will do that because you forgot to do both the positive and the negative. Okay, here we go. Get rid of this. Okay. Oh, what did they do? They took everything here and multiplied it by 5, and they took this and multiplied it by 5 to clear the denominator. Okay? 5 times cancels 5, leaving 2b. 5 times 3 is 15. 5 times 6 is 30. Yes?
This one is a question. You always have to get the absolute value on until you get the absolute value.
Listen to my pun. You absolutely must. Okay? All right, so we can finish this one. Subtract 15 both sides. Divide both sides by 2. And we get 15/2. 7.5. What about the other side? Well, we're going to do it the same way. We're going to multiply this, all of this by 5, multiply all of that by 5, just like I did here. And leaves me this. So I'm going to subtract 15 on both sides again. Gives me that. Divide both sides by 2. And I get negative 27.5. If you want to convert it to a, if you needed to graph this, yes, you would need to convert that to know how far to draw the dots. Okay, question about this one. And those values will check it. It's kind of a pain. But. So there are your solutions. Decimals. Yeah. Actually, as long as you clear the decimals, they're not that horrible. I'm going to move the decimal over one place. Okay, I'm going to show another step first. I've got one digit behind, one digit behind, one digit behind, no digits behind. Right? Okay, so I'm going to take all of this, wait a minute, all of this, and all of that, and multiply it by 10. Because 10 moves us one digit. Okay, 6.9 times 10 is 69. That gives me 69 here. That gives me 41 there, minus 10p. Because remember, technically there's a 1 here, and if you move that decimal over one place, you got 10. Okay? Plus 69 again. Now we're ready to continue with this thing. Okay, so I better erase my scribbles. Hope you wrote them down. Actually, that's what I wrote down. Yes.
So say for instance, you have like 6.90 and 4.1, and you just have 4.10 and then 6.9.
Extra zeros on the end don't matter. But what if you had 4.15, which is what I think your question really is?
Yes.
You look at all of these and you see which one has the most decimals behind. If it's one digit behind, you multiply everything by 10. If even one of them has 2 digits behind or 3 digits behind, then you would multiply it by 100 or 1,000. Someone say I don't get it?
Oh, no. Just you multiply by 5. Like however many you have, that's just you just keep going up.
Yeah.
This is a non-negotiable. You just got to do it.
Yeah. Well, you don't have to. You can make it hard.
Yeah, I don't like making it hard.
Okay, so anyway, they decided not to. They decided not to, for whatever reason. Okay. So what they did is they got rid of that 6.9 right there. They subtracted 6.9. Actually, let's see what they did. From this step to that step, all they did was split sides in their work. Okay. Then, let's see what they did next. They ought to be taking this over to the other side, which conveniently gives us a 0. Now, let's just see what happens. They're going to tell you this right up front. But the reality is, if you tried to work this, we can now get rid of the absolute value and have 4.1 minus p equals 0. Find a better pen. Subtract 4.1 on both sides. Giving me negative p equals negative 4.1 and positive p equals positive 4.1. Okay. Over here, on the other side, well, plus or minus 0 is just 0. So there's no point in doing this one twice. Okay. Well, wait a minute. We got this over here. Well, negative, positive 0 is still 0, so it wouldn't matter. And there you go. I'm going to erase my scribbles.
You see their scribbles.
And see their scribbles.
So it's not no solution?
No,
You can have an absolute.
it's negative. Yeah.
So there's only one answer. There's no positive, negative answer. There's one answer. That's it.
What they're saying is the positive answer. Well, actually, there would be, because we would get the 4.1 either way, the negative 4.1 either way. So 4.1 is the answer. And that is the only answer in that particular problem. Okay.
So this one.
Yeah, so if you try to negative 4.1 in this, it won't check. I hear some murmuring. Where are the questions?
Okay, so what was the point of multiplying by 10 to get one decimal if I still end up on
I never finished that.
Okay. I was following along, but I was trying to write it down. And
Okay.
41.
69 equals 41 minus 10p plus 69. Minus 69 minus 69, 0 equals absolute value of 41 minus 10p. Right there, you can see you got an issue, but we can take away the absolute values. 41 minus 10p equals 0. There is no plus or minus 0, so we only have to do this once. Minus 41 minus 41. So we get negative 10p equals negative 41 divided by negative 10. And p equals just positive, because these two negatives cancel, 4.1, because you divide 41 by 10 and you get 4.1. Now, on this problem, it was simple enough that clearing the decimals really didn't make it that much easier. But there are other problems that it'll make a big difference in how easy. And that just depends on the numbers.
But it's like a good practice and a good habit.
It's a good habit. I mean, it'll never let you down. But it, you know, it may or may not be faster on any given problem. Yes.
So what would you say would be a good example when you look at that and you get like, I think I should have to put this.
Well, you saw my immediate reaction. I'm going to change it. I don't like working with decimals. Down here, I ended up dividing by 10. Okay. But what if down here, I ended up dividing p equals 41 by 7.34. I mean, that would be possible if you made up the right problem. I don't like doing this where I have to do this. Okay, well, move over to, put the decimal and work it. I don't want to do that. I don't even want to do that on a calculator, which you're not allowed to use. So in a problem, if you had not nice numbers, not numbers like 10, it would be very beneficial. Did I finally answer your question?
Yeah.
Okay. What's my favorite motto for the class? Work smarter, not harder, for Carter.
There's also the little steps is fine, the bigger steps better.
Yeah, well, but that doesn't apply in this case.
I'm trying to remember important phrases.
Okay.
I'm trying.
How important they are remains to be seen. Maybe it's just the blatherings of an old man. Here they're doing the check on this thing and they get approved. Okay. Two absolute values. Good one. Okay, now. You really don't do them any different. It just so happens in this particular problem that both absolute values are isolated. They won't always be. There might be some add-on stuff on one of them, okay? But you've always got to get one side or the other totally isolated where all it is just a simple absolute value, okay? Remember, that was that first step in that list I showed you. So, in this case, we're dropping the absolute value symbol here and there. Okay, that makes this, when we take away one absolute value, we take away both absolute values. Now, in this case, look what they've done. They've got this and they've got that. This problem would make more sense to you based on what I told you already if I wrote that. Because here's my plus or minus. And the plus or minus is always on this side. So if I were working this problem myself, I probably would have included this with an arrow over to here and an arrow over to there. I probably would have inserted that step. Just so I absolutely didn't forget to do both the plus and the minus side. Okay, we'll continue. Here, the left side, we're just going to combine like terms, okay? We'll take maybe this 5W over there, take this -3 over here. On this side, we've got to distribute this negative first and make this -5W and -1. And don't forget to do the back half of that parentheses. Big error pattern there. Okay, I need to get rid of my scribbles again. So they're taking the left side now. They took the 5W over here, and this step from here to here, they took the 3 over here by adding +3 +3. Okay, so now they just got variables and numbers. Gonna have to divide both sides by -3. You know, I'm saying these steps. If I were you guys, I would be writing these steps in as we go. Okay, and then -3, -3. I would be doing those. Okay, and you get -4/3. The other side, similar manner. We're going to take the 5W over here. Then we're going to take the -3 over there, or add 3 to both sides, I should say. And then we're going to divide both sides by 7. Yes.
But now aren't you gonna have to do the same thing with the other side of the equation as well?
What do you mean?
Are you gonna have to do the same thing with 2W - 3 to make it positive?
I did. Way back here.
No, we
Here
only
was
made,
my positive and there was my negative.
no, we only made one side.
You do only make one side now. What? Always the right side. Always the right side goes to positive and negative. Okay. And there's your answer. Now, I'm going to teach you a little bit of mathematical trivia. In your packet, it's probably like page 5 or 6 or something like that. There's a fraction decimal percent sheet. Yes, 5. Thank you. Look at the fractions that are sevenths. What's happening?
It's getting longer.
It's starting to repeat. Remainder 1, remainder 3, remainder 1. And here's the 3 remainder, then we'll have a 2 remainder, and then we'll have a 6 remainder and a 4 remainder. It's starting to repeat, right? And this is going to go 1, 4, 2, 8, 5, 7, 1, 4, 2, 8, 5, 7, and carries forward. That's what those 3 dots mean. And carries forward in this manner. So it's just going to keep repeating, or we could just use a repeating bar like that if we wanted to. Okay, but I'm going to put these back up there for a reason. What's the answer to this? The answer to 2/7 is 0.28571 and keeps going. How did I know that without dividing? Look at the pattern on my sheet. 1/7 is the smallest number and it starts with the 1. 2/7 is the next smallest and it starts with the 2. 3/7 goes up to the 3rd. And 4/7 and 5/7 and 6/7, and then it starts all over again, forever. Okay, that's just a bit of trivia for
So 3/7 goes from.
3/7. There is no 3, so the next smallest one is a 4. So it starts off 4, 2, 8, 5, 7, 1.
Okay.
And 4/7. Okay, here's the smallest, second smallest, third smallest, fourth smallest. So it's going to start 5, 7, 1, 4, 2, 8. Okay, well, just a bit of trivia. May or may not ever be useful to you. If you want to go into engineering and stuff, you probably need to memorize all those decimal conversions. Okay. All right, another problem, another double problem. Which side are we gonna plus or minus? The right. Do we have to do any mechanisms first? No, because there are no add-ons. Okay, so this is the plus side, that's the minus side. We talked about that already. Okay, start simplifying this. I'm going to take this x over here, and all the x's go away. X minus x is no x. And I end up with a falsehood. This is a contradiction. Remember us talking about those earlier? That means this answer won't work. Well, let's try the other side and see if we're more lucky. Okay. Well, first thing we do is we distribute that negative, getting this business. Now we're going to add an x to both sides, and we get 2x. We add 4 to both sides, we get -4 divide, and we actually get a valid answer on this side. Okay, so you can have problems like this. Will they all be like this? We've already proven they won't. Just some will. And only the -2 is a solution. Okay, inequalities. Okay. We've talked about all of this is the same stuff that we talked about with whole numbers so far. You know, an absolute value can either be a negative a in there or it could be a positive a in there. So we have to do the plus or minus thing. So far, all that's the same. When you graph just an equation, you get individual points, or no points, as the case has been for some. But when we do inequalities, then we have a continuum, just like when we had inequalities before with equal signs. Okay? All the numbers that are less than something, all the numbers that are greater than something. We can have and or, intersection and union again. Okay? So all of that stuff before still holds true. Plus now we got to deal with the inequality symbols. Well, and there's a between this one, right? That one's certainly an and. So here's a problem, let's try. Now this is a single absolute. We don't have any add-ons on the, oh yeah, that 4 is an add-on with the absolute, isn't it? So we got to get it over on the other side. It's our first step. So we did that. We added +4 to both sides. Now we can drop the absolute value and make this a plus or minus 11. Just like we did before. And let me put that step in there lest you forget it. 3w plus 1 less than plus or minus 11, which generates those two equations. All right, so you can look down through these steps. Okay, I just put them all up here at one. I decided not to animate it after I typed those in. This problem didn't originally have the answer. Okay, so you get W is less than 10/3. Okay, out here is 10/3. W is less than that. We work this side with the negative. We bring it down. We get W greater than -4. Here's -4. Now, one bad point on my graph is I should have had -4 labeled. I should have had 10/3 labeled, and I should have had 0 labeled. Okay. Do as I tell you, don't do as I did. Have you ever hear your mom say that or dad? Okay. Well, anyhow, why did I reverse this? And by the way, when I reversed it, when I reflected it, I did switch symbol, didn't I? I flipped symbol. If I put the answer in set form, I may need that. Just wait and see. Okay, now, here is the basic set formation. If I put down a set of x values such that that. Okay. Now, what is this thing going to be as an answer? I'm getting ahead of my slides. This thing is going to look like here and here and everything in between. Okay. Now, for doing this, see, this one's already in the right direction for this statement because the bigger end is over here on the far right. But the littler end, to get it to be true, I have to flip this and put it in there. Now, what is the interval notation? That's one other thing we could still do on this problem. -4, ending point not inclusive, 2 in thirds, also not inclusive. And that would be the interval notation. Questions on this one? Yes.
So when you were basically saying that you flip it, you're essentially just saying that you're only flipping it to get the smallest number of days in the order.
Pretty much, yeah. I mean, I could make it a more technical answer than that, but in reality, yeah, that's what I'm doing. Hey, any other questions on this? I'm going to erase this before I hit my next slide. Which probably is going to say what I just wrote. Well, there's the set notation. There's the graph I already showed you. And they did label it. And here it gives you your answer in set notation as we discussed, and also in interval notation as we discussed. That one looks kind of scary, doesn't it? Step by step. Okay, just use those steps, you know. One step at a time. Don't let the whole of the problem freak you out. You look at this problem. I'm trying to tell you how to think right now, how to strategize for this problem. I see this problem. I see that I'm scared. Well, maybe not really. I see I got to add on. I got to get this thing by itself, right? So let's get rid of that add-on. How are we going to do it? Add -1 to both sides. Okay. Now, they did an extra step before I did. So they'll have their variables on the left already. They flip sides right now. Now, you can work it either way. Probably a good idea to put the variable ones on the left and also the absolute value, but you can work it the other way, yes.
So you're allowed to literally just take it and put it as long as you put in your sign.
That's exactly right. Notice this symbol. Okay, so now that we got it like this, we still got to get rid of that 1. So we're going to add a -1 to both sides, resulting in this. We got isolation. So now we're good to go to remove the absolute values. Which gives me my 2 problems because I've got to have the -2 and the +2. They switched on me. They did that to show you it doesn't matter whether you work the minuses on the left and the pluses on the. Me, I always put the minuses on the left just for consistency. And also on square roots when we do those. That it's just a consistency thing that might help with error prevention, okay? Legally, you can do it either way. Well, they decided to put the negative on the left. So now we take this 5 over to the other side. Okay, we're gonna take the 5 over to the other side. And that leaves us with 1/2 t less than or equal to 3. Multiply both sides by 2. The half and the 2 cancel. You get t less than 6. Over here, similar process. We're going to take this -5 to the other side by adding 5 to both sides. Then we're going to divide both sides or multiply both sides by 2. These 2 cancel, and you get t greater than or equal to 14. And we're going to go to the next slide up at the top. Anyone not ready for me to go? Okay, so based on this original problem, we now have these 2 answers. We conveniently have the variable on the left both times. Okay? So what do we need to do? We need to graph this thing. T is less than or equal to 6 is 6 inclusive and everything smaller. Yes.
Would that also be, would we still, even though it is for the positive, we still have to put 0 on the left?
Oh, you want me to do this?
Yeah, like, do we
On this one, no, not so much. But generally, it's a good idea to put your 0 anchor point. But on this one, I don't know that it matters that much. Okay, so anyway, we go on, we graph this one, we graph that one, again, inclusive. Now, this is a classical, whoops, what did I do there? This is a classical OR statement just by its design. Because there is no inclusion of both, there's no overlap. Okay, so in this case is your answer, this stuff or that stuff. And that's what this statement right here says in absolute values. Now, I may be about to answer your question before you ask. We'll see. There is no way you can write a statement like this in one string on an OR statement because you can't get a truth out. Okay? Because no way in this can you show that gap in the middle. Okay? Yes.
How come the sign flip for T is greater than, or less than or equal to 6?
Where are you talking about?
The-
Here.
Yes. So how did that flip?
To get that -1, to make that one side negative, to get the negative side of it, you have to swap the side.
Okay, here we have the negative sign there. +5 and +5 is +3.
Okay.
It's just the numbers, not an always rule. And then we got rid of this half by multiplying both sides by 2, getting 6.
So you multiplied it by +2. Why did the sign flip? That's what
They
I'm
didn't
confused
split.
about.
Those are consistent all the way down.
So it flipped on the other side?
This is
Yeah, I didn't bring that up as we went through it, and I'm actually kind of glad she taught that. When you take the negative side we did flip symbol. Well, what we did right here, okay, this one, this original problem, okay, we put that stuff over there, this stuff over here, and we had to, on the negative side, you do have to flip if you reflex. This was the original symbol. When I just turned this around, notice this is opposite.
Oh, so when you put the absolute.
This one is a double opposite because of the negative side.
Okay. I didn't catch that you flipped the absolute to the left side.
Yeah. Okay, thank you. All right, let's look at this one. What?
When you go back to where it shows the solutions at, right there where it says, oh, board over there,
Where?
keep board, keep going. Basically where it shows the answer.
Whoops.
Right there.
Right there.
Where it shows T and then the line of T, is that saying, what is that?
This statement, the set of t values, remember before we had answers like t equals the set of 5. Except we didn't always show the t equals, but it's there. Or we had t equals the set of 4 and 2. Okay. This is just saying here that we've got a set of t values that behave according to this rule, is what it's saying. I think I went over that last class, so. Okay, and you weren't there for that. Okay, and for our interval notation, we look right off the graph, reading it left to right. We start at negative infinity. We go to 6. We got a gap. We got a 14 inclusive to positive infinity. And this union symbol shows that we're going to take anything that's in this piece of answer or anything that's in this piece of answer and count it as correct. And I could pick a point right here. I could pick 18. Positive 18, and I could put it into that problem and check it, and it would give me a true. Okay, that 18 is bigger than 6 or something like that for the check. Okay. Did that answer your question? Okay.
So on the test, do we have to like both of those? One of them
Unless I ask for this one, then the default is interval, which as you see is much easier.
Yes.
Well, no, I got to do that at least once or twice. Okay, here's another one. We got to get rid of the 7. Okay, so it becomes that. We don't need to go any farther because that's an obnoxious noise I just made, but
How about that? Way too low.
okay, kind of like the old buzzer in game shows. That's what that's supposed to be anyway. Okay, this time slightly different problem. We get rid of the 7. Still got an. Why is this one everything and that one was nothing? Look at the direction of the symbol. Look at the direction of the symbol. Less than -3. That means I've got the absolute value is going to be a negative number, which I can't have. On this one, after I move the 7 over, it's going to be something bigger than -3. Okay? And I'm just telling you that's going to be it, because I'm going to go through the y right now. If the direction of that symbol makes a difference if you got a negative. Okay,
So, question, hypothetically, if we had to graph that, will we just pick two numbers?
No.
Well,
Line arrow, no input.
it'll take me about 5 minutes to prove this to you, but I'm just gonna lay that out there for right now, because I'm gonna do some more stuff. Well, this one isn't a whole lot. Uh-oh, you know what? A lot of these problems we've been doing up until now have been less than's. Let's see what happens on a couple of greater than's. Is that a scratch in your head or a question?
Well, so just so I can clarify, we're only losing the absolute value once we start that process of the addition subtraction.
Okay, now. See that symbol? 0. Solution is again infinity to infinity, just like the last one. Because it's going to be some number bigger than 0. Okay, or equal to in this case. And absolute value of 0 is 0. Okay.
So if it's any number higher than 0,
Yeah. Okay. Well, let's work this.
question.
I'm sorry, I keep asking. So, if I were to, write any answer, would I like to like abbreviate this if I can? So you said that we can use the R with 2 lines to print real correct. Can we put that with our answer?
Alex won't accept that.
Okay.
Which I think is really where you were going with that. Okay, so anyway, this thing simplifies to that. Oops. There, like so. Okay. Now, because of this, notice I'm dealing with equals now instead of the greater than. And that, okay, subtracted 2 on both sides. Okay. And it doesn't matter negative or positive 0, so it's going to be the same answer either way, only one answer. Okay. So this is saying that x is -1/2. Can that be true? No. It can't be true. So what this is saying is there is a gap at -1/2. This is a union. Now, so what your answer is in this is x is not -1/2. Okay? Or the way of writing this statement is infinity to -1/2, -1/2 to infinity. Now, if that had been a less than, then we would have had. Okay. All right, there's another one, similar. This time, it's only that point -1/2. With it this way, it's the point -1/2. With it that way, it's the gap -1/2 and everything else. Because remember, everything else that we've had with these have been infinity to infinity. But that gives us this one exception. Okay. Okay. We get to skip that, and we actually get to skip all of this. And I need to switch to chapter 2. What? Oh, not too bad. Okay, linear equations, line generating equations. Okay. Y equal mx plus b is the most important rule you can learn. Look in your packet. I think it's somewhere close to the front, maybe page 7 or 8 or 9, or I don't know. 7. There's a list of linear equation formulas. And look at also page 8. No, not page 8. Okay, just stay in set page 7. Okay. The one that I just talked about, y equal mx plus b, what's its formal name? Slope intercept equation. That is the most important formula in all of what I'm about to do for a long time. Okay, 2 or 3 class periods. So let's go on. First, I got to make sure you guys know how to graph. How do you graph? Well, this is called the y-axis, y high, x across. Okay. They number outwards from the center symmetrically, both up and down. When you go in for a CAT scan, they are doing a 2-dimensional graph of your body, making a figurative axis on you and measuring points within that way. And an MRA is 3-dimensional, but that's a story for a different night. We call the intersection of the x and y axis the origin. It's divided into 4 quadrants. Now, these quadrants have characteristic values for their pairs. Now, we write numbers like 2, 3. In this case, starting here, the x value is always first, the y value is always last. So, starting from here, we count lines, not spaces. 1, 2 for x. Then we're going to go up 1, 2, 3 for y. That point would be represented right there. Okay? Now, likewise over here, these are going to have characteristic signs. This will be positive x, positive y. This one will have characteristic negative x, positive y. This one will have characteristic negative x, negative y, both negative. And this one in turn will have positive x's, but negative y's. Okay? So that's the general layout of graphing. Yeah, bungee around my wrist with this thing. Okay. By the way, these things, these points are sometimes called ordered pairs. Okay. X value, Y value called coordinates. No big deal. Okay, if we did these problems in a graph, there they would be located. Just take a moment, compare them, make sure you're feeling okay with this. Now, this point we describe as being on the y-axis. That's the way we describe that one. That one we describe as being on the x-axis. Okay. Now, there's a characteristic that will always show up on that. If it's on the y-axis, the x value must be 0, because it's neither left nor right. Okay, like so. That's going to be extremely important later. If it's on the x-axis, then the y value is 0 because it is neither up nor down. Okay, now these two terms together are called the intercepts. The x-intercept and the y-intercept. That means where does the point encounter, or the line, encounter the x-axis, or where does it encounter the y-axis? Now, if a problem ever asks you, what is the intercept? You must give your answer in a point format, not just a value. If I ask you, what's the y-intercept on there? So you couldn't just tell me 3. You would need to write down 0, 3. Very important. By the way, in Alex, don't put any spaces anywhere in that.
Otherwise,
It will count it wrong.
We'll lose a point in X part of it.
Yep. On that problem, yes.
No, on the entire, your set.
On the whole module. you
Okay.
get 3 in a row.
Well,
Well, if you got 3 or-
do we need to go over where these are? Okay.
Yeah.
Now, this is kind of a nonsense thing, don't write it down. That is what we call standard form for an equation, for a linear equation. We will use it some, but it's kind of an elite snob. I mean, it's like the tuxedo and the formal dress of line equations, okay? The overalls one is y equal mx plus b. And that's the one that'll get you answered most of the time faster. But there is an occasional use for this, mostly in finding the intercepts. Okay, standard form. Why the disclaimer? Because if either that x or y are missing, then it's not the equation of a line. Well, actually, there is 2 exceptions to that for the vertical and horizontal lines. Okay, here's an equation in standard form. The first skill you need to do is you need to be seeing if there is a point, is that point a point on this line? Example, here's my graph. Here is the point, -4, 0, right there. They want to know if this point is on a line described by that. Now, for right this minute, we're not going to graph that line, but we're going to prove that that is a point on that line. Is what this skill is asking us to do. So we just simply replace the x and y with the values. And if you get a truth, then that tells you that yes, this point truly is on the line generated by that equation. Okay? And here's the wording we use for that. The ordered pair is a solution of the equation. Okay, what about this one? Is this one a point on that equation? Well, let's sub it in. We get a falsehood. That means that that point is not on that equation. Is this ordered pair a solution? Only difference in this one and the other one is it's harder numbers. Okay, so we sub it in. We simplify it. Those 3's cancel, by the way. And we get this. So -2 and 10 makes 8. So it matches. So we're good to go. Okay. And here's some more to try. Now we're actually going to get started graphing. when this says all ordered pairs of solutions, that's a line. A line is for never. Okay? Girls, that's why you never want to listen to a line from these guys. Because it never ends. Bad joke. Anyway, we want to graph this equation. Okay? Well, we can make what's called an XY table. Okay, an XY table. We just arbitrarily pick some X values and or some Y values. Just arbitrarily. Anywhere in this graph, you pick one, but you don't pick both. Then what you do, this X generates that part of an ordered pair, this generates that part, this generates that part. Then you take the equation and solve it in for each one. If X is 0, then you replace the 3 with 0 and you get Y as 3. Okay, so on until we get this set of values. Okay, and that gives us a set of ordered pairs. Those ordered pairs, in turn, we graph. Okay. Now, takes a minimum of 3 points to get an effective graph on a line. Minimum. Okay. You can do as many as you want, but minimum 3, yes. Okay. Do you know why? You know why?
The third one checks.
Well, that's true, but why? I can put down 2 points and they will always set and create a line, right? If I try 3, if any one of those is just slightly off, it's no longer a line. And so 2 to build and 3 to check is kind of the general rule. Okay, here's another one of those. We pick some X values. By the way, this is called the independent variable. You pick whatever you want to be independently. This is called the dependent variable because it is a result of what this one is. This one depends on that one in that equation. Okay? And so we did the same thing on this one we did on the last one. I'm just skipping the arithmetic. This one, and this is the last one I'm probably going to do, or one like it. This is in y-intercept form. This is the real way to graph. In y-intercept form, slope-intercept form, I should say, the x is the slope. Not the x itself, but the number in front of the x. That tells the angle that the line is going to go at. It's going to go up 1 across 3. Okay. This gives you the y value of the y-intercept. Okay. So if I wanted to graph that equation, I can start with this. What is the y-intercept? It's the point 0, 1. Okay, by definition, right here. That becomes my anchor point. Now, from that anchor point, I'm going to use this slope formula. In slope, we use capital M to represent, for some reason, is always the amount of rise over the amount of run. Okay, always. So what we spread my parentheses out to include it. So what this means, and I need to take a brief explanation. They got this problem written right here. This value also can be written like this. Rise, run. Also can be written as this. Those three are all the same. This one and this one both make that one. Okay, but when it comes to slope, here we're going to go down 1, right 3, because positive is the right direction. This one we're going to go up 1, left 3. So here I go down 1, right 3, or I go up 1, left 3. Okay, and then from that point, I would go down 1 and right 3, and down 1 and right 3, and down 1 and right 3, and up 1 and left 3 ad nauseum. There's my line. Now, isn't that easier than making a box?
Yes.
Absolutely. And this is the way we're going to do it 90% of the time in this class. And with that, I say, happy weekend, happy holiday Monday.
See you Tuesday.
Yes, I don't want to see you till Tuesday. There are still 3 or 4 of you who do not have your integers sheet into me. You need to be doing that.